So now that we have at least a structure that is rendering something on the screen, you notice that we are approaching things almost like in this rookie level, right? We have been creating this global variable projectile that holds the position, a projectile velocity, all these things like global variables. We're hard coding those things. That is not what we want to do if we're talking about a game engine, right? We want to have more flexibility. I don't want my game code to have this keeping track of the player position, the tank position, the light position. I want things to be more flexible. So that is why I think it's good for us to kind of stop and think about what is going to be the next step. What is going to be the architecture that we're going to approach with our code to allow these things to be a little bit separated from each other. I used to have a tutor back in Oxford, Seppi, and she used to say, Gustavo, think of a game engine as this application that knows nothing about the data from our game. So think of it. Your game engine goes and reads almost like your game is a database. So the images, the PNG files, the sound, the sound effects, the script for the movement of the players, everything is in this database. Your engine goes, fetches that data, right, loads, and then based on that data, it starts running the cogs and making the gears move. And I like that thought. What I want to do is, my engine knows basically nothing about the game that is loading. So if we want to load a game, we fetch that data, and we start running the gears, and then we see things moving on the screen. If I want to load a different game, I just go and I connect to a different database, right? I fetch that data, and I start loading those things, making the gears move, and then loading a different game. So I want to try to kind of decouple these things, right? I want to have this division of responsibilities between my game engine and actually the assets of my game, how my game actually behaves. Fair enough, I don't think we're going to be able to achieve 100% of the division of these responsibilities, but that is what I want to at least tackle. That is how I want to tackle these things. I want to think about things as this very dynamic, flexible, divided, right, separate responsibilities. So that is why I want to take a moment and talk about this idea of what we think as this entity component approach that we're going to try to achieve. So the idea is, how do we organize our game objects? If you think about from a very abstract idea, right? Let's think about the mathematical abstraction. We have a game scene, and we add things, right? We add this abstract idea of things to our game scene. So I can add a thing, I can have another thing that might be very similar to the first one, right? It might have the same color, it might look the same, it might behave the same way, but they might move similarly. And then I can add another thing, which is basically very different from the first one, right? Another color, it looks differently, it behaves differently, it triggers the actions differently. I have another thing, another thing. So I have this abstract idea of adding things to my game scene. And the word thing is very loose, right? I'm using it very loosely. So whenever we think about things, you might be used to thinking about, okay, these things are objects, right? In the world of CPP, they have classes, you have objects. Each object, you can go and you can inherit some properties. So I might take to my benefit the use of, I have a thing, and then if I have actual obstacles like my player, my enemy, some obstacle in a wall, maybe a light, the camera, all these things might inherit from this parent class, right? My thing that I add to my game scene. That might work. That is actually a valid point. Some people actually go and implement those things. I don't think I'm going to do that right now. I don't think that's how we're going to approach this, especially with C++. There are cases, and especially in game development, there are cases where your player, it doesn't have to inherit things, and they have very different behaviors and very different properties from the camera, and they do have different properties from a door or an obstacle, and etc. So yeah, I'm not going to approach things like that, especially because C++, C++, you can inherit from several parents. So you can have this multiple inheritance, and sometimes inheritance has some issues, right? You can inherit from some parents, and you have those diamond inheritance where the parents inherit from the same parent. So whenever you call a method, you don't know exactly where is the parent method that you're trying to call. So diamond inheritance, all these issues, especially with C++, I want to try to avoid these things. So yeah, we're not going to go with inheritance approach today. what I want you to think is, let's think about something that we're used to, right? Game objects. Whenever I say game objects, you probably something that's in your brain that says, I've seen the idea of game objects, right? This word game objects before. So if you think about Unity, you add a game object in your scene, that game has a name, the game object has a name, and it has some properties, right? What we call the components of your game object. So you have a transform with the position, rotation, the scale. You can say if the game object collides with something else or not. Do we have a sprite? Do we have a texture? So these components here, that is how I want to approach things. That is kind of exactly the same idea on how I want to put the skeleton of my code to work. So that is why you will see people talk about the entity component. People talk about entity component system, right? But I want to talk about this entity component relationship. So the whole point is I go and I add entities to my game scene, right? I add this entity. That entity can be the main player. I add another entity that might be my enemy. I add another entity, which may be just something that it doesn't even appear, but it's just a door trigger when I cross my door. So maybe I want to cross my door and I want to trigger some zombies to come and, come towards your player. You want to maybe activate some particles whenever you cross that trigger. So again, you collide, you trigger something. Those things are entities, right? And the whole approach is, besides the entities, you have this small other objects, which are called components. And they have this behavior of, let's say, if I have an entity, I can plug, I can add, and I can say my entity will have a transform component. And by transform component, I'm thinking mostly in 2D things like the position, the rotation, how much it scales, maybe even the velocity if I want to add there. So the transform component of my entity. My player entity, I can also go and add a new component, right? The collider component. So my player, besides having a transform, position, rotation, and scale, I also can have a collider. So that collider might have a little rectangle, which is the bounding box, right? So what happens when I collide? What does it trigger? And then that is my player. Now my enemy. My enemy, it will have also a position, rotation, so it does have a transform component. And my entity, enemy, might have a sprite component with animations, right? With different frame rates for animation, but it shows something on the screen, right? It has a sprite there. And by sprite, I mean a PNG file, right? Or an animated file. If I think about my door trigger might have a collider component, right? So it might have position, etc., but it collides with something. So if I trigger that collision, I activate a script or I do something else in my game scene. So, and again, my door trigger might not have a sprite component to it. So this flexibility, right? It's dynamic. I can add new components to my entities. I can remove the components. I can add new entities to my game scene. This is the approach that I'm going to tackle with our little game engine. So let's start thinking about planning. Let's stop for a moment, take a step back and start planning our classes. I think I'm going to have what I call this entity class, right? And this entity class, I think of it as having a list of components, right? So I do have this other class that is called a component. We're gonna see in a bit. So these components inside my entity, each entity has a list of components, and each entity also needs to be able to know how to update and render itself. Thinking about the class components that I just mentioned, each component needs to know how to update and needs to know how to render themselves as well, right? So an entity has a list of components where each component updates and renders themselves. But the component is actually a parent class, right? It's actually a superclass where the actual implementation of the update and render is responsibility of the components itself. So my transform component, which inherits from component, needs to go and it needs to override and implement update and render for itself. The sprite component needs to go and override the implementation of the parent, update and render. The collider also has an update and render. You have to go and override. The particle emitter component, if you have, has to go and override. So this is the structure of kind of bird's eye view of my entity, which has a list of components, my components, and then the inheritance that I'm going to have because the component is my parent class. Let's think about the code, right? So let's just give a little pseudo view of how I think the code should go. Class entity, there we go. I'm going to use a vector, the standard library vector, right, to keep track of pointers to components. And the name of it is components, right? So components right here is the list, right? Is the list of component pointers that is going to have, that my entity, every entity is going to have. I need to be able to add components, right? So I have there, I'm going to have an add component property. We're going to see how this works a little bit later. I'm going to use templates. So we're going to review how that works as well in C++. And each entity can have an update and a render. I think we need to have also a class which is called the entity manager. And I think I'm putting this entity manager inside my game.cpp, right? Inside my game code. Because my game needs to be able to call the entity manager to add a new entity, right? Because my entity manager has a list of entities, pointers to entities itself. So vector, right? Vector of entities, a list of entities. I can add an entity that goes and adds to this vector. I can kind of get the entity with a string entity name. Maybe my entities have a little unique identifier, which is the name. And my entity manager is responsible for updating and rendering all the entities that it has. So having an entity manager that is responsible for adding, removing, destroying the entities of my game. And also let's look at the components a little bit better, right? So my parent class component, I open my class and I think I like to keep track of, for each component, I want to keep track of what is the entity that is the owner of that component. So each component has an entity which is the owner, right? So who is the owner entity of that component? Who is adding this component? And then I have these two virtual methods, update and render. Why are they virtual? Because who is responsible for actually implementing these two methods is the class that inherits from a component, right? Let's say the transform component. Transform component, I'm just going to keep things very simple, right? I have a vector to position, right? Where it is x, y, and z, or x and y in our 2D game. So I have a position, I have a width, a height to keep the dimensions of my object. I have a scale. I'm not adding rotation here, but we're going to have rotation. And then update override, because it has to override from the parent, and then render override as well, because it's the transform that is responsible for telling how to render itself, how to update itself. I can have also a collider component, right? And a collider component extends from, right, it inherits from public component as well, that's the parent. Let's say that the component is only a little rectangle bounding box, right? With an SDL rectangle. It's a pure struct. It's simply a struct that keeps track of the rectangle position and then what is the width and height of the rectangle. So my collider component, which I'm calling the collider here, is just a rectangle, and then also update and render both overrides from the parent class. Very quick bird's eye view. I think that's how we're going to try implementing our game. I just like to kind of sketch things on paper later. That's what we're going to tackle. Right, so I just want to keep track, I want to make sure that we understand what is our new game loop and how these things relate to each other when it comes to updating and rendering everything. Do you agree that we're going to have still a game.cpp? So our game is going to be responsible for holding the entity manager, right? And the entity manager is that thing that holds, adds new entities, removes entities, destroys them, etc. So our game, inside our game.cpp, we're going to have our entity manager, and our entity manager, inside my entity manager, we're going to have a list of entities, right? And for each entity, the entity manager is responsible for calling for each entity, the entity update and the entity.render. So each entity will know how to render and update themselves. Then I'm going to have a for loop there, right? I'm going to have a loop that inside my manager, I have a loop that updates and renders all the entities. But for each entity is going to be responsible for holding a list of components that I have just added, right? So transform component, sprite component, particle emitter, collider component. My entity holds a list of components, and my entity is also responsible for looping for each one of its child components and calling their update and their render. So do you see how I have these cascading responsibilities, right? My game holds the entity manager loops all the entities, all its entities rendering and updating, and each entity inside my entity manager is responsible for looping all the components, updating and rendering them. And this is my new game loop, right? And this is going to happen in my game loop frame by frame, right? That is, I update everything, I update all the entities, update all the components, update and render. New frame, update new entities, maybe check for input, update, go through all my components, update and render. So this is all this kind of cascaded responsibilities. This is the nested way that I'm looking at my new game loop. And that's how we're going to approach the development of this. So what I want to do right now is, I think it's good for us to kind of step back and start coding. Let's start maybe from bottom up. Let's start coding the component. And then once we have the component kind of skeleton, we go to the entity, because the entity has a list of components. And then we go to the manager, and then we add things to the game function. I'm going to be honest with you. It's going to take a little bit of time. We're going to have a lot of code to create all this kind of the basis, right? The foundation of our whole game engine with the entity component system, but it's going to pay the price, right? We're going to have later just say add entity, add components, add this new entity, new components, and then they are responsible for updating and rendering themselves. So let's check in the next lecture how we go about implementing them.